So in this video, we are working with question 5. The first question says f of x is equal to cos ax. And it's asking in 5.1.1 the value of a. So we have to look at that graph, the cosine graph or the cos graph. So this one is the cosine graph. Notice it starts on a high. It starts at -1. It starts on 1 and it ends on 1. Okay, so starts on 1, ends on 1. Notice it goes down to -1 at 90 degrees. Now normally the cosine graph goes down to -1 at 180 degrees. So remember that a full wave is between 0 and 360. So 180 will be the lowest point of a cos graph. So at the highest point, it's 1 and 1. At the lowest point, the y value is -1. Okay, so when I say 1, 1, I'm talking about the y values, okay? And the lowest point is -1. This is a normal cos graph for 0 and 360. So here, normally, what will our equation be for our graph? And because there's only one graph for this domain of 0 and 360, or for this period within 360, there's only one graph. So cos x is actually cos 1x. Okay, so look at this graph. Notice if I draw this graph here where the Parker pen is, and I draw it all the way up to 360, how many graphs am I going to see? I'm going to see 2 graphs. And if I'm going to see 2 graphs, then this would be my equation for it. And then I know the a value now. A would be equal to 2. Next one, 5.1.2, it says the period of G. Now G is the tan graph. Notice that the first one is approaching to 90. Okay, can you see as it goes up from between 0 and 90, we find that the graph is curling upwards towards the 90, but it won't touch the 90 because that is the asymptote. So if it's going up there, and you're only seeing this part of the graph. Now notice if I had to continue finishing off this graph, would it finish off at 360? Definitely. So that is a normal tan graph, right? So remember the asymptotes are 90 and 270. And the graph would look like this if completed. Right? And in the other way, it swings the other way. So that's what the tan graph would look like. Notice where does the graph repeat itself? Can you see where it starts to repeat? The graph repeats the shape from 180. Therefore, the period is 180. The next question says the value of x for which negative tan x plus 1 is equal to 0. Now, a graph that is negative tan x would look something like that. It would be starting at 0 and moving down there. Now what would the graph of negative tan x plus 1 look like? So the orange graph would be negative tan x plus 1. So plus 1 means the graph moved 1 square higher. So the question is asking, what is the value of x for the graph minus tan x plus 1? What is the value of x where this graph is going to be equal to 0? Now pause the video and give it some thought. What would be the x value looking at the orange graph where that graph is equal to 0? So they're trying to say the y value must be equal to 0. What value must x be where the y value is equal to 0? Okay, that's what it's trying to say. Pause the video, think about it, write your answer. Besides graphically, we can also work this out mathematically. Negative tan x plus 1 is equal to 0. Take the plus 1 over to the right hand side, I'll get -1. Drop the negatives on both sides and solve for x. Tan is equal to 45, but there's no need to calculate, so you could just look at the graph and write the answer 45. Okay, and it's just how many marks for that? 2 marks. So if you write the answer only, you will get full marks. 5.1.4, they're asking for the range of G. So they're asking for the y values of the tan graph. Now notice that curve is going all the way up to positive and negative infinity. You with me? So if you look at that first one with the Parker Pinners, it's going all the way up to positive infinity. The next curve is going all the way to negative infinity. So therefore our y values will be, so our answer is y is the element of negative infinity and positive infinity. 515's question, it says where f of x is less than 0. What does that mean? This means the graph must be negative. So the question says for which values of x is the graph negative. So all I have to do is look at the graph and look below the y-axis to see where is the graph negative. Now between the two pins we can clearly see between 45 degrees and 135 degrees, this is where the graph is below the line. So notice between 45 and 130, between, and because it's between, we're going to use curly brackets. If it's including the 45, notice at 45 and 135, the graph is not negative, it's a 0 at that point. Okay, so they're asking where is it negative. So this is why I'll put curly brackets, because when it is 45,0001, this is where the graph now becomes negative. But at 45 itself, the value of y is actually 0. So notice, where is the graph negative? Between 45 and 135. Now G180 minus F180, they want to know what's the value, right? So all you have to do is write down what is the y value at G of 180, and write down what is the value of the graph of f also at 180. So graph f, what is its value? So notice the silver pin, there the value is 1. So if you look at it nicely, your value is 1. If we follow the line, we can clearly see the value is 1. So 0 minus 1 is minus 1. Now in the next question, they're asking the graph of f, right, which is the cosine graph. They're asking for which values of x does the graph decrease. Now decrease means the graph is going down. So the graph is decreasing between where and where? Look at it nicely. Now if we look at those y values, 1 and minus 1, notice at that point, that is the turning point. And notice those are the x values, 0 and 90. So they're asking for which values of x does the graph decrease. So notice it's between 0 and 90 degrees. This is where the graph decreases. So don't write the y values, write the x values. Which values of x is the graph decreasing? So x is the element of 0 and 90 degrees. So between those two values, 0 and 90, the graph is decreasing. But at x is 0 and x is 90, those are the turning points. Okay, the turning points. I know the question doesn't have this here, but I'm going to ask you, give me the coordinates of the turning points of the graph of f. So it's not in the paper, I'm just adding this to explain some things. Okay, so I'm not going to call it 5.4. I'm just going to ask you, what are the turning points of graph f? So we know clearly that the x values are definitely 0 and 90, right? We established that in the previous answer. So now, what will be the y values of their turning points? Let's see if you can see it. Okay, that's where the pins are. Okay, where the pins are, that's the y values. So, and it will be 1 and minus 1. We're in November 2024, question 5, and now we are saying draw the graphs. As you can see in question 5.1, it says sketch the graphs of f and g on the same sets of axes on a grid provided. Indicates all the asymptotes, intercepts, and the axes and the turning points. So you must label all those things to get 6 marks, 3 per graph. So in the question paper, this grid will be provided. I'm just going to draw it here, right? I'm not going to print the grid and do it. 90 and 270, we have our asymptote, right? So this is for the tan graph. So remember, it curves towards the 90. So the graph curves towards the 90. It goes through 45 degrees. It is 1. Okay, so tan 45 is 1. There's my dot there if you can see it. And then from 180 it curves towards the 270. But this is only if I'm drawing this graph for 0 to 360. Notice here it doesn't say draw it for 360. It says the domain is 0, 180. So from 180, it will go the other way towards the 90. So notice it's only the blue that must be drawn, not the green, okay? Only the blue. Why I drew that in just to understand the shape of the graph. Now the next graph is sine 2x. So this means there will be two graphs for 360 degrees. You with me? Two graphs. This means for 180, I'm going to have one graph. One full completed cycle of one graph. Don't forget that sine starts on a low. Don't forget that sine graph starts on a low point. Sine of 0 degrees is 0. Sine of 90 is 1. Okay, so to get the curve, you can do this. Substitute 0 where x is, right? Then 90 and 180. What's your answer for all of those? Okay, and that's how I get my 3 x-intercepts. 0, 90, 180. Put my 3 dots, and then just somewhere in the middle, you're going to put a little dot there in the middle of those two, and you're going to draw it. It's as simple as that. Now you're going to need your graph to be accurate to answer all the questions that follow, else they're not going to be correct. So you have to have an accurate graph. Make sure you can draw these graphs, okay? Practice them. Now f of x equals g of x. They're trying to say, where are the graphs intersecting? Where are the two graphs cutting each other? So look at it and write down the coordinates. So at x is equal to 0, we can clearly see the two graphs are equal at that point. At x is equal to 45, the two graphs are equal at that point. At x is equal to 135, the two graphs are equal at that point. Also, at x is equal to 180, the graphs are equal there at that point. Now the graph of g is sine 2x. They're asking you, if you multiply that graph by 2, what is going to be the amplitude? So multiplying the graph by 2, and the number in front of the sine, that is normally the amplitude, right? I'm sure you know that. So the number in front of sine 2x, this number is the amplitude, so therefore the answer is 2. Now I know the question doesn't ask to draw it, but let's just draw that graph on top of our existing grid paper, okay? Just for our practice, let's just draw it. 2 sine 2x, how will it look? And so the graph in red will be 2 sine 2x. Next is question 524. Now these questions in 524 can be difficult to understand, right? These seem difficult. Please listen carefully. Notice they say the resultant new equation h. Now there's no h there in that diagram, okay? We only had g and f, okay? And what is the equation of g? So g is the one on the screen. Gx is equal to sine 2x. Now they're asking the graph of h. Which one is the graph of h? Think about it. So the graph of h, they said you must halve it, and they said you must also change the range, okay? So if you look there, they said we must halve it, and also we must change the range, okay? So that means it's going to go -5 all the way up to +5. This means there's a 5 in front. So notice that if we halve the graph, it's going to compress even further, right? If we halve it, this means there's going to be an extra 2 graphs within there. So it's going to be sine 4x, and then the amplitude will be 5 in front. And so for that, it's going to be 2 marks, the 5 and the 4, okay? So when it says you're going to halve it, this means you're just going to change that number, that 2x to 4x, okay? When it says half, don't go and simplify it by saying 2 divided by 2, and it's going to give you x. You'll be making the graph bigger, not halving it, okay? Remember, learners, you must do irregular shapes. Question 11, it's a must do. You must do this on your own. It's a quick 5 marks or 6 marks on average.